Hello my dear students, today we will start part 2 of the electric lamps. Now let's know what is the meaning of the electric circuit. Can you see now in this picture? It's a closed path and a continuous path through which the electric current passes, making a complete circuit. For electric circuit you need battery, wires, lamp and a switch. The battery works as a source of electric current in the electric circuit. The wire, they connect the battery to the lamp, and the lamp is used to indicate the passage of the electric current. And the switch, it will close and open the circuit. So, the electric current is a flow of electric charges or electrons through a good conductor of electricity. Can you observe these two pictures? What is the difference between them? Here you can see that the light lamp is lightening, while here is not. Why the light lamp here is lightening? Because as you see, the circuit is closed. So there's a flow of electrons in a closed circuit. While here the circuit is opened. So it's opened circuit. So we have two types of the simple circuit. Closed circuit and open circuit. In the closed circuit, all the parts are connected together. The electric current passes and the light lamp will light up. While in the open circuit, the parts are not connected together. The electric current doesn't pass and the light doesn't light up. We have two methods to connect the electric lamps together. The first one is called series connection, and the second one is called parallel connection. This is the series connection, and this is the parallel connection.
Spikey and Bubbles were playing with the ball when it hit the chandelier and the string of decoration lights. Something interesting happened next.
Oops, this is bad. We should have gone outside to play. Hey Bubbles, isn't this strange? Only one bulb of the chandelier has gone out. But for the decoration lights, all the bulbs have stopped working. But why?
Good question. It's time to learn about the types of circuits. An electric circuit is a path along which electric current flows. A simple circuit has a cell, a bulb, and a switch connected by wires. But what happens when there are two bulbs? How can we connect them?
Well, we can connect the second bulb right next to the first bulb.
Or we can connect it above the first one.
Well, let's see who's right. Let's make Spikey's circuit first. We need a battery, a switch, 3 bulbs, 2 that work and 1 that's burned out, and connecting wires. Let's set up the circuit. Now, let's add another bulb right next to the first one. What happens to the brightness of the first bulb?
Whoa, it's dimmer.
Exactly. Now replace one of the light bulbs with a burned out one. What happens?
Both the bulbs go out.
This is a series circuit. If all the electrical components are connected one after another in a single loop, then it is a series circuit. In a series circuit, there is only one path for the current to flow. The amount of current that flows through each bulb of the circuit is the same. Now let's try Bubbles' suggestion. We'll add another bulb above the first one. What happens to the brightness of the first bulb?
It remains the same this way.
Correct. Now replace one of the light bulbs with the burned out one. What happens?
The burnt out bulb does not glow, but the other bulb is still glowing. It is not affected.
Excellent observation. This is a parallel circuit. If all the electrical components are connected in two or more loops, then it is a parallel circuit. In a parallel circuit, there is more than one path for the current to flow. Each loop is independent, so the current in one loop will not affect the current in another loop. So, now we know that both Spikey and Bubbles were right. Spikey connected the bulbs in a series, whereas Bubbles connected the bulbs in parallel. Hence, there are two types of circuits. One, series circuits, for example, decoration lights. Two, parallel circuits. Our home appliances are always connected in parallel.
But why? Why don't we use series circuits in our home?
Because series circuits come with a disadvantage. Let's take a closer look with an example. Look at these bridges. They are connected one after another in series. You can cross these bridges easily. But what happens when one of the bridges collapses? Can you cross to the other side?
No, we can't.
Exactly. This is the disadvantage of a series circuit. A break in any part of the circuit stops the flow of current in the whole circuit. Another disadvantage is that the more bulbs we add to the series circuit, the dimmer they become. Now look at these bridges connected in parallel. What happens when one of the bridges collapses? Can you cross to the other side now?
Yes, because we can use the other bridge to cross to the other side.
Well done! This is the advantage of a parallel circuit. When there is a break in one of the branches in the circuit, current can still flow through the other branches. Also, the brightness of the bulbs remains the same since every loop is independent. Now, can you explain the chandelier and decoration lights problem you had earlier?
Oh yes, it makes sense now. Only one bulb of the chandelier went out because it is connected in a parallel circuit. One broken bulb did not affect the current in rest of the bulbs. But for the string of lights, all the bulbs went out because it is connected in series. One broken bulb will stop the flow of current to all the bulbs.
Good job! Let's summarize. There are two types of electric circuits. A series circuit is one in which all the electrical components are connected one after another in a single loop. A parallel circuit is one in which all the electrical components are connected in two or more loops. A disadvantage of the series circuit is that a break in any part of the circuit stops the flow of current in the entire circuit. But a break in any part of the parallel circuit does not.
Start with the series connection. As you see in the picture, it is a way in which the light bulbs are connected one after another in one route on the same way. So, there is one route for the electric current to pass through the circuit. It only passes in one direction. But in the series connection, all the lamps are on the same route. So, if one of these lamps will burn, what will happen to the circuit? It will be an open circuit, so the other lamps will turn off. So, when you cut one of these routes, or one lamp burn, all the bulbs are turned off. Give reason. Because in the series connection, there is one route for the electric current to pass through. When the number of the bulbs connected in the circuit increases, the lightening of the bulb will decrease. Now let's talk about the parallel connection. Can you see it? There are two routes to the electric current to move. So, it is a way in which the light bulbs are connected in a branching route. This is a branch and this is another branch, parallel to each other. The electric current has more than one route to pass through the circuit. So, as you see in this picture, there are three routes to move the electric current. The electric current can pass through this lamp from here, and can move through here, and can also move through here. So, when we cut one of these routes or lamp burns, the electric current moves in the other bulb and they will keep lightening. As the number of bulbs increase, the current intensity and the lighting bulb remains as they are in the same intensity. We have a very important comparison between the series connection and the parallel connection. The first point of comparison is the definition. In the series connection, it is the way in which the light bulb are connected one after another in one route. While in the parallel connection, it is a way in which the light bulb are connected in branching routes parallel to each other. The light intensity in case of the series connection decreases by increasing the number of lamps, while in the parallel connection remains constant by increasing or decreasing number of lamps. It cannot affect each other. The effect of the burning out or unscrewing any of lamps. In the series connection, the other light bulbs were turned off, while in the parallel connection, the other light bulbs are lighted up with the same intensity. Now in our daily life, we use these connections. How is that? As you see here, number one, all lamps and machines in houses are connected in parallel with the main source of electricity. Why? To avoid turning off the rest of the lamps when one lamp is turned off or broken. The decoration lamps, which are used in occasions and celebrations and weddings, are connected in the way that ensures if one or more lamps are burned or broken, the other lamps doesn't turn off. Why? Because the lamps are connected in a parallel connection. Time for evaluation, and this is your homework for today. Write the scientific term, a way in which light bulbs are connected one after another in one row, where the light intensity of the bulbs decreases by increasing their number. 2. A way in which the light bulbs are connected in a branching route and the light of the lamp is not affected by increasing their number. Give reason. The light bulbs are connected in the house in a parallel connection.
Hi, I'm Jared. Welcome to Fun Science Demos. Kind of in the dark today because we're talking about electricity. And to show you electricity, we need to light up some light bulbs. And to light up some light bulbs, we need it a little bit dark. I have in front of me an electrical mystery. In another video, we talked about the idea that electricity needs a path to move through and follow. Scientists call that a circuit. Take a look at these two different circuits I have in front of me. These circuits look almost the same. They both have batteries. They both have a switch to turn them off and on. They both have wires and they both have light bulbs. So how are they different? Now remember, electricity needs to move through a path. It has to follow a path. So let's take a look at this blue side. Let's see if we can follow electricity. So electricity is going to come out of my battery, and if I turn on the switch, it'll move through the switch, through this wire, through this light bulb, through this wire, through this light bulb, through this wire, back into the battery. It's a circuit, a circle that electricity will flow through. Let's see if it works. Now I'm going to turn on our switch to complete our circuit. And we have the light bulbs lighting up. But they're not very bright. These light bulbs aren't bright at all. I mean, I can barely see light coming out of these light bulbs. There's got to be a reason why. I think by taking a look at the red side, we can start to figure out the reason. I have my circuit, a battery, electricity flows through this wire, it'll flow through this switch, through this wire, through this light bulb. Wait a second. I think my electricity can travel a different path. I think it has some options. It doesn't have to just travel one way. I think my electricity can travel two different ways. Let's take a closer look and see if we can see the path that electricity will move through. So let's turn the switch on and see if we can actually follow the electricity as it moves through my circuit. I have electricity coming out of the battery through this wire, through the switch, through this wire, and when it gets to this light bulb, my electricity can move two different ways. It can move through this light bulb and then back through this wire back to the battery, or my electricity can flow through the wire, through the switch, through the wire. It can then pick up with this wire, flow through this wire, through this light bulb, through this wire, and back to the battery. There's two different paths running at the same time. So why are these light bulbs so much brighter than these light bulbs on the blue side? Well, think of it like this. As the electricity moves through this wire and it gets to this light bulb, it doesn't move so easily through this light bulb. This light bulb slows it down. So now the electricity can't move as easily through these light bulbs, so it's dimmer. But look at this. The electricity flows through this light bulb and back to the battery, but we also have electricity flowing in one path. It doesn't move through that light bulb. It moves up through this wire, through this light bulb, and it can flow easily in a different path. Now remember, when I look at the blue side, the electricity only has one path to follow and move through. One. On the red side, my electricity has two paths to follow. It can go one loop, or it can go a second loop. Scientists call any kind of circuit that has one path a series. Scientists call any kind of circuit that has two paths to follow parallel. So using science, we've solved the electrical mystery. And believe it or not, circuits are all around us. These switches are just like the light switches on your wall. And every switch can start or stop the move of electricity through those circuits. It's pretty neat.
Thank you for watching. See you next lesson.